Okay, so greetings, dear audience. Today I'll be reviewing my grade 9 and grade 10 math notes. And yeah, I combined everything into one book. I have 15 to 30 minutes until I need to go to campus for lunch and then class. So I'll try to cover everything right now. I also need this knowledge slightly for my university courses at the moment, and I'll be reviewing it with no copyright lo-fi music. And so, page 1. Oh, it's in the frame. Okay. Integers. I know this. Ratios. Rates. I got that. Exponent rules are something I need to review and look into, because even though they're simple, I've been forgetting it quite a bit, unfortunately. So exponent rules. It's let me zoom in. Okay. Here's a bracket you multiply. If it's a multiplication, it distributes into. If it's a fraction, it distributes into. Same thing down here. Okay. It's exponent laws, linear relations, dependent, independent, variables that stand alone and isn't changed by other variables. And so this is time. You're trying to measure the amount of studying you can get in a certain amount of time. Okay. Studying depends on time. Okay, so, all right. You calculate slope by rise divided by run. You take 2 points and y2 minus y1 divided by x2 minus x1. All right. A vertical line, its slope is undefined, but a horizontal is 0. This is really important for calculus, because when you have a function, they're gonna ask you to find the point on the function at which the slope is 0. And so you'll take the derivative of the function and do something with it. So this is an important rule to remember. And I know it, yay-hoo. This is a standard form, okay. Y-intercept. If you have a line and to find another line that's perpendicular to it, you need to take the negative reciprocal. It's flipping it and putting a negative sign. That's something that's probably used in vectors in grade 12 and in a university, because the cross product of 2 vectors is a perpendicular. I'm not sure, yeah, that's probably wrong, but that's a connection. Okay. Right. The volumes. Haven't gotten through much of this in Calc 1, so I'll skip that. This is probably really helpful and will be useful in my physics labs, because I'll take a lot of data points and I'll need to find the line of best fit, which is exactly what I did for my lab last week and my report I had to write yesterday. I had to find the line of best fit and explain why does the force of mass reduce as it's dipped into a container of water. So the line of best fit showed the graph was going down, and I explained that the object, since it's denser than water, it sinks, but when it's suspended, the balance reads a lesser weight, and so what is it? The object submerged in the water displaces equal volume, and that the mass of the water displaced is the amount of weight reduced on the balance. So this is very important. I think I should know this. Scatter point, line of best fit. I don't need to write this down. I know this already. Just draw a line that's best fitting to the data points. Substitution is really important, and I have been using it very consistently. I know this. We use this extremely often in vectors in high school and university. Elimination is a form of substitution. It's different. It's been 7 minutes and I'm done a few pages. Okay, I think I need to go a lot faster. I don't need to know elimination, but substitution works awesome. This is super important in vectors because it's used a lot in vectors. Verifying systems of equations. It needs to be equal, okay. Quadratic formula. Right. Vertex is the highest or lowest point. Line of symmetry splits directly through the quadratic function. The y-intercept intersects the y-axis, so is the x-intercept. The domain is a set of values for which the function is defined. Range, okay. Max, min, lowest or highest point. That's the x value, that's the y value of the vortex. Okay. Can be written in standard form. I think grade 9 ends over here. Yeah, grade 9 ends over here, and so grade 10 begins over here. I remember doing this very well in grade 10. I followed a YouTube video and filled out these notes in the classroom. And the standard form can be factored and turned into a factored form. Direction of opening, plus minus constants, take the two x values divided by 2 and the x value, axis of symmetry, and find. I don't think this is very important at the moment in calculus because I haven't seen it a single bit. A factored form is really important. It's opposite. X equals to positive s, and x equals to positive t. You just flip it, basically it. The equation of a parabola. So finding the a value, that's what's explained over here. You place the value of the y-intercept and the value of the x-intercepts, and so you place the zeros, and then you place the y-intercept. Oh, okay, and then you replace the x-intercept thingies, the x with zeros. Oh, because you could either replace, because the x and the y-intercept here is 0 comma minus 5, and here it's 1 comma 0 and minus 5 comma 0. I don't need to know this really. This is important because I'll be writing a lot. I need to know these. I know them, yay. Converting factor to standard form is super important. I need to know it for calculus derivatives. We do a lot for simplifying. When you have two factored form equations, you need to expand both factored form equations and then combine them and factor them again. Okay, so now we're coming to factoring, converting a standard form equation to a factored form. And there are several ways you can do this, and they're all summarized over here. Factoring is something I definitely need to practice. Factor by grouping, I know very well. Factoring by simple trinomials, I know very well too. I messed up in my first calculus assignment in university, and this is, I just flipped the places and I got it wrong. This is used extremely often when, I know how to do this, and this is slightly annoying, but I can do this very quickly. Oh my god. I think this is my favorite page of the entire notebook because I explain it really well with just lines. I'm gonna skip the ad. I'm not talking in circles. Okay. So for the entirety of high school and all this time in university, the only factoring I've seen so far is everything here. I've never ever used perfect square trinomial, factoring perfect square trinomials. I'm not sure if you'll ever need it. I haven't seen it. It's probably important, but I should write it down, but no, I'm good. Solving quadratic equations. What is this? Solutions to quadratic equations are known as the roots or zeros of the equation. Okay, so zero product property. Get rid of any fractions by multiplying each term by the LCM. Oh, yeah, that's quite important. I do know that. Actually, let me use these things. So I needed to know just a little bit of these. And so I'll just place that right there. And yeah, that's a nice system. I know how to do that. I hate word problems, but it's crucial to apply my knowledge in real life. So I need to get a hang of this. We don't have any word problems in courses in university yet. So stretching and reflecting. So this is easy. This is quite easy, but for what is it? Trigonometric functions, it gets quite difficult. I think I wrote it down somewhere. Or it's probably in my second notebook. Yes, right here. Oh, okay, well, I guess we're covering grade 9, 10, and 11 math in this notebook. Oh, okay, oh well, that's great. I have another notebook, and this is entirely grade 11 and 12. That's for another video. So it's the same thing. Greater value in front of greater value for the constant. It's a vertical stretch. A smaller one is a vertical compression. A negative constant is flipped, and a negative d value flipped here. Okay, everybody hates this. It's the opposite of here. Like inside the bracket, if it's a larger number, it's a compression, whereas here it's a stretch. So it's a larger number, it's compression, but it is compressed by a factor of 1/4, which is so annoying. Okay, I messed up so many problems because of that. Everything else is exact same. It just, this thing is gotta be so bad. I have no idea why. Horizontal compression. Okay. Stretch. STRET. Okay. The step pattern, it's super important to graph functions easily. Oh, I know that theme. Oh, okay, cool. Right, so you just take the step pattern and multiply it by a constant, and it just all stretches or compresses. Right? I explained it here for horizontal translations. Trashlations. Okay. Trash. TRAN. Vertical trashlations. Okay. Yeah, okay, I know this. This is me crashing out, I guess. Nope, I didn't crash out. This is translations, yeah, it's a translation. Okay, graphing quadratics in the vertex form. Okay, so we introduced the, what is it? Introduced the vertex form somewhere, apparently. Huh. Solving for K. Okay, I guess I didn't introduce the vertex form. I just jumped right into it. Oh, right, okay, this is the introduction. So, vertex form is quite nice to graph functions. Partial factoring, let me see. Find the first symmetrical point. Method 1, this is so time consuming, you don't need to know it at all. Neither is completing the square. It takes a lot of time. And I think the best form to use is method 3, is where you take this part of the quadratic formula and just find x. And you put that x value into the skeleton. You find the y value and put it into the skeleton and take the, what is that thing called? Oh my god. Let me search it up. What are the parts of a quadratic function? Quadratic function equation. Coefficient! It's not a constant. Oh, okay, yeah, alright, so this is the constant. 1 here would be, that invisible 1 would be a coefficient. And yeah, okay, yeah, alright. That's a coefficient. Alright. Alright, so this is the fastest way to convert standard form to vertex form is by using the half-sliced quadratic formula. Meaning I don't need to know this or this, but if the teacher asks me to do it, then in university, they're not gonna ask me to do it. Alright. It's only in high school where they'll force you to use a specific format. Solving quadratics. Bring k over sine. Huh. Solving quadratic equations using the quadratic formula. In many cases, when the standard form equation cannot be factored using any of the tools, like any of these, then you'll have to use the quadratic formula. It's really easy to memorize. X equals minus plus or minus square root of b squared minus 4ac divided by 2a. Okay, yep. And then you just flip it and flip it. Put the same coefficient down here, and you got your answer. This is me, second semester of university, writing on my grade 10 notes. Okay. These are the points of intersection of the quadratic formula in standard form. Been through this. Half cut. The discriminant of the quadratic formula. I've barely seen this at all. I don't think I need to know this. Trigonometry. Trig. Alright. It's a branch of mathematics. Congruent, opposite, alternating. Trigonometry is super important and the most annoying part of math, I think. It was fine in middle school and it became worse and worse. This is just my grade 8 knowledge I thought would be useful, but we don't really need it. Yeah, I copied this from my grade 8 notes, grade 7 notes. Don't need that as well. Don't need this either. Primary trig ratios, okay. SOHCAHTOA, that's all you need to know from this 2 pages. That's the opposite across the angle, adjacent along the right angle and the angle, and hypotenuse is the longest. Yeah, this is super important. Sine law. Unfortunately, I haven't seen the sine law as much. I don't know why in university, but yeah, I don't know why. Oh, right, in mechanics, engineering mechanics, oh, right, I remember now. Last semester in engineering mechanics, we are analyzing static structures, and so we need to find the angles of beams, pulleys. So it is used a lot. I don't need this at the moment. Cosine law, probably my favorite. Sai Shrikara, why'd you do this to me? Boy. Oh, right, okay, yeah. Uppercase for angles and lowercase for sides. Opposite, capital A from this point is small a on this side. Super important. Word problems. Does the question involve angles? Okay. This is analytical geometry. Super important for vectors. It's like prerequisite skills. On vectors you have a y-axis and an x-axis, and you do everything you possibly can on that plane. And in university vectors, you include the z-axis, and in high school too. And you do all sorts of crazy things with it. Yeah. Formula to find a midpoint. I don't need to know this. This is... I don't need to know this either. Finding the length. The line segment. Usually in vectors, the line just travels indefinitely. You don't need a specific line segment, so skipping that. You will need this. I had a question asked during a vectors test previously, so yay. I remember it's just you take two vectors, CA and CB, and you take the cross product of that, I believe. Is that right? How to find the area of a triangle using cross product. Let me see, is that right? You take two vectors, take the cross, oh, okay, and divide it by 2. Oh, alright. And something with the parallel piped, and something else with a 3D shape, parallel piped. I forget what that was. Area of a triangle. Rational expressions. This is it's still grade 10. Yeah, it's still grade 10. Okay. Rational expressions. Extremely ultra important. Yep. Factor, cancel out, state the restrictions of the denominator, because the denominator cannot be equal to 0. And you have a factored form, a simplified form. Huh. And you shouldn't state the Shouldn't state the restrictions. Let me see. Should I state the restrictions after simplifying a rational expression? I'm asking Google. Huh. Apparently you should. Well, this is me editing my notes again. Oh. What? I think I'm going back to grade 9. I remember failing a test in grade 9 about simplifying these things. Huh. Is this grade 9 or grade 10? God damn. Or I didn't fail the test. I didn't do it because I didn't learn it, because I didn't attend the class for it, nor did I study for it. So I opened the test and my teacher, Miss Backbag, just said, take it on another day and study for it. And so I was like, okay, I'm so sorry. And my dad and I studied. Same denominators. Oh, functions and relations. This should be grade 11. Yes, it is grade 11. This is grade 11 review. So should I cover my grade? I think I will cover everything I did in grade 11, yes. every value of x has two values of y. So if this is a graph, 0, 1, 2, 3, 1, 2, 3, 4, 0 would be at 2, 1 would be at 2, 2 would be at 4, and 3 would be at 4. So it will look like this. And it's still a function. It'll look like this because it passes the vertical line test. So every value of x has only one value of y. Every value of x has... So this little table here also means 0, 1, 2, 3, 2, 2, 4, 4. This works, but x, y, 0, 1, 1, 2. This is not possible because, and I can just put any value like 2, 3, 4, 5, because the graph of this is 0, 1, 2, there would be 2, and then at 1 there would be 3, and then at another one there would be 4, and there would be 5. So graph would look like this. Passes the vertical line test. Oh, okay. So this graph, since there are two values, of y per one value of x. During the vertical line test, right through, let me see if that's even, we're getting recorded. Okay, yeah, okay, that is getting recorded. Right there is two values or infinite values of y. So say that we have this function. It's not a function because there are two values of y at one point of x. This cannot happen. So same thing. There are infinite values of y along one value of x. This is not a function. So if one x value diverges into two y values, it is not allowed. But when two x values diverges into one value, it is allowed. Okay, yep, I understand. I actually never understood why this worked before. I just wrote down what was on the board, but I actually figured it out now, so I'm quite happy about that. Vertical line test, right? So in my grade 11 culminating assignment, I'm supposed to draw my face using just functions. And for all of the functions, I just wrote y equals 2x plus x squared. I lost a lot of marks because I'm supposed to use function notation and not y. So that is an important thing I learned. Right. Degree of the polynomial is 3. If the degree of the polynomial is 3, it's a cubic function, and so it's gonna have, okay, it's gonna look like that. La 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 la. Rationalizing the denominator. Okay, I saw this yesterday in my course. Very important. Yeah, very important. Radical rules. I keep forgetting my radical laws. That's something I need to consistently review every day because I can make a lot of silly mistakes by just not knowing this. Yeah, okay. Right. Word problems for business. Oh, that's odd. Let me see. That's odd. Okay, it's not covered. Everything I need is right here. Okay. When you want to find the points of intersection between a linear and quadratic function, you just make it equal to each other and find and factor the function and solve for the x's, and that is your intersection points, and you solve for the y's and you get the x and y coordinate. If it is a cubic function and you have a line passing through, you need to find 3 x values. At that point, you would use the SOAP rule. It's a new way of factoring. It is somewhere here. It is definitely somewhere here. I need to find it. Hey, yeah. Oh. Yes. No. Oh, yes. Yeah, right here. Oh, okay, I should get to that. Alright. Let me see. Yep, I know these. New exponent laws, okay. Are the same exponent laws. I need to know this anyway. This stuff in grade 11, I will use extensively in grade 12 physics or university physics. Oh yeah, kinematics, right. Exponential functions. Okay. These are some random notes. It's laws that I suddenly found out and I needed to know it absolutely, so I wrote it at the end. And this is super important for grade 12 advanced functions. I despise that. I know this. And this is also super important. I guess I should mark these pages. And mark this page. Right. Because these are quite important. Compound interest. And this thing, oh my god, destroyed me so much. I actually had to, even though I studied this in grade 12, grade 11, I did not understand it at all. In grade 12, I barely got through it, and it's actually just a few days ago I understood this part of trigonometry. I mean, I understood this before, it's just I actually deeply understood it a few days ago by studying it a lot. Cast rule, right? Let me see. Okay, that's still good. Mm-hmm. These special triangles are all I need to know. You don't need to memorize this at all. These special triangles are really important. These, right? These angles can be rewritten. Since pi is 1/8. Oh, let me write that larger. Since pi is equal to 180 degrees, 45 degrees is just pi divided by 4. And so all of these can be written as pi divided by 4, pi divided by 4. Over here, right, 60 degrees, pi divided by 3, 18, right? 6 times 6, 12, 18. So pi divided by 3 is 60 degrees, and half of 60 degrees is 30 degrees, so you just multiply the denominator by 2. This is really important for radians. 30 degrees is pi by 6 radians. 45 degrees is pi by 4 radians. And so you can derive these just from doing primary trig ratios on these triangles. We are introduced to some more. These are reciprocals of the primary trig ratios. They are quite important. Oh, right. This is the principal angle, the reference angle, the negative coterminal angle, and so the angle starting from 0, that would be 1 positive coterminal. Oh, right, since angles are always positive, they go like that. So a positive coterminal angle would be 360 plus the principal angle. Another positive coterminal would be 360 times 2 plus the principal angle. Same thing applies for this negative coterminal angle would be 360 plus 180 plus 180 minus the principal angle. Quite confusing if you're listening to it the first time, but it is very easy. Very easy. the vector pointing outward from the origin is called the terminal arm, and the vector aligned with the x-axis is the initial arm. So the initial arm is terminated and, I don't know, flies into another angle. Yep, that's what I explained back here. Where is my Castro, man? God damn. What the? Oh, okay, well, that's the next page. This video is gonna be 1 hour long. I'm not gonna edit these videos because I don't have time for that. Everything I explained in the previous page. Pause the video, take a picture. Oh yeah, that is the Castro, right? And I think I feel like I wrote the Castro down somewhere. I think it's back here. It should be back here. If it's not back here, I will cause destruction. I feel rage. Extreme amounts of rage. No, 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 no. Please be here. I'm begging you. Okay. At this point, I'm losing my mind. Where is it? What? Physics, right? No, calculus. It was in calculus. Physics? Should be in calculus. Huh? Oh, what? Vector spaces. That's wild. What? Oh, okay. All right, I'm happy. It's been here this entire time. This is what I wrote in grade 11. But I understood it, and then I forgot about it. In grade 12 functions, what is it? In grade 12 functions, I didn't do a couple lessons. These pages were blank, so a few days ago, I learned everything and did them. I'm very happy that it's here, because I was really scared that it was not there. Okay, onward with the video. Ambiguous case of sine law. You don't need this. I haven't seen it at all. Maybe I'll need this in the future, but at the moment I don't. Periodic functions and their properties. Sinusoidal functions are ultra important. Oh my god, the birds look beautiful. Oh, the sun is setting. Oh, I want to go outside. I haven't explored the city yet. I'm quite sad about that. But, oh well. Let's see. To find the amplitude, you subtract the maximum value by the minimum value, so it's somewhere here, and you divide that by 2, and you get only the amplitude, the equation of axis. Oh, okay. So you take the maximum value, which is like this, and you subtract the minimum value. Which means you're basically adding the values. Subtract the negative value. So it becomes like this. And then you divide it by 2. So it becomes like this. So you get the amplitude. Okay, alright. Equation axis, you're trying to find its location. So if it's shifted up, you're trying to find the location of the equation of axis. You take the max value, you add it by the minimum value, but actually you're just subtracting it. I don't need to know this, okay? I don't need to know this because we're not doing this in university, but if you're in high school and if you're getting ready for grade 9, 10, 11, or 12, you absolutely need to know this because you will encounter these problems. But I'm just saying I don't need to know this. Cycle is one complete pattern from 0, to back to 0. One period is the horizontal length of one cycle. So one period of this black function would be 2 pi. Pi being 180 degrees, 2 pi would be 360 degrees. So if you were to shoot an arrow at a wheel and you graph its location, it would look exactly like, so if you shoot the top of a wheel in a car and it travels one full period, which would be 360 degrees or 2 pi, the arrow would go down to the bottom of the wheel and go back up to the top of the wheel. It'll look exactly like a sinusoidal function, even though the wheel is round. Yep, that's my little piece of example. This is also probably one of my favorites. I like the way I drew my arrows here, so yay for me. It is taking this complex looking equation, sinus trigonometric equation, and actually graphing it out, because the vertical stretches, the horizontal compressions, they can really throw you off if you're using some other method. I don't need to know this, but you do. I realize this video is just me saying if I need to know this or not. I'm not really teaching anything to anybody other than my examples, but I guess I'm learning stuff that I forgot. Yay for me. This is also quite important. Period equals 2 pi over k. I guess I'll need this for physics too. Converting sine functions into cos functions, because as you can see here, this is a sine function, and it's just also the same as a cos function, but just shifted to the left by 2 pi, or pi over 2. So over here, a sine function is just a cos function, except it's translated to the left by pi over 2, but since it's inside the bracket, sine to the left is pi over 2. Cosine moves to the right. Oh. The sine function moves to the right. The sine function moves to the left, right? Move the cosine function. Oh, okay. Move the cosine function to the right by pi over 2 to make it look like a sine function. Okay. Okay, that was quite confusing. But in university, you don't, or I guess for what I'm studying, you don't need to know this. But in grade 12, you definitely need to. Okay. Right. Holes occur because of the round brackets, but in solid points occur because of solid square brackets. That's quite important. Okay, this is just homework. That's a Tesla valve. That's a Tesla valve. This is French homework, hence why you see in French over here. I remember this assignment. I remember this assignment too. Right. That's grade 9, 10, 11. And let me very quickly skim over grade 11 and my grade 12 functions notebook. This is the graphs of the sine and cos, and this is also pi over 2, right? Okay. K value, all right. Arithmetic series, sequences, recursion formula. I don't think I'll ever, I don't think I'll need these anytime soon. I'm not sure when my teacher taught this. It's probably required for some other course, but in engineering, I don't really think so. I think it probably might. I haven't seen it yet. So I'm gonna skip arithmetic sequences, geometric sequences. No. I think I'll need this in the future. Recursion formula. General formula. Geometric series. Pascal's triangle has theory behind the concept of infinity. I remember my calculus professor a few days ago talking about it, about the theory behind infinity, and it's not as easy as it seems, and you can delve into several lectures. So I'll just say Calc Pro. Business functions. Okay. This is not required for engineering students unless you want to start a business as an engineering student or working business in the future. I personally really enjoyed learning business several months after I finished the course. I didn't enjoy it at all during the course, but it was quite important and simple interest, really easy. Compound interest, future value. Okay. Let me put this. One second, I'll be back. It's been exactly 1 second since I was gone. So I guess 1 second I'll be back. My statement stays true. Right. So, simple interest is the interest earned or paid only on the original sum of money that was borrowed or invested. Okay. Simple interest is trash, but it's a basic, important concept for business. The most powerful concept in investing. So currently I invest in a bunch of stocks, and I've used these formulas a lot to understand how to invest and like grow my wealth, understand how finance works. Simple interest, never seen it. Compound interest, future value. Right, so in simple interest, you invest a sum of money, and then after a certain duration, you need to pay a little more money on top of, when you borrow some money, okay, after a certain period of time, you need to pay a fee for borrowing that money for a period of time. So I guess that's simple interest. It's not trash. I take my words back. It's a basic, important concept for investing or anything finance. Same thing for compound interest. You invest a sum of money here. So you invest a sum of money, and then every year you basically make free money. You basically make free money constantly every year. Or your money grows as the company or whatever you invested in does well. That was an hour and 15 minutes. And so eventually in the future, your $100 invested into, I don't know, some ETF index fund would turn into maybe $5,000. But compound interest future value is definitely weaker than what's in the future. What's definitely weaker than annuities future value. It's annuities future value is much stronger then compound interest future value. It's basically the same thing, but in annuities, you pay money right now, and instead of waiting for like 30 years and then selling all um, your stocks, you invest right now, and yeah, you invest right now, and you gain a little interest on top of that, and then you invest more money the next year, and then you get your interest or your profits would be based on what you invested right now, what you invested before, and the interest you have made on what you've invested before. So that would add up into a bigger box. And then next time you would invest a little money, and then the profit you would make is on top of these 3 investments plus these 2 profits, so you'll make a larger profit. And so over the years, while the money you make through simple interest might look like this, through compound interest, it might look like this. In annuities future value, it's going to be a lot steeper, and you're not going to make money really fast, because you're not going to make money really fast, honestly. You need to surpass investing, like, you need to have $100,000 in your portfolio, and that first $100,000 is going to be really hard. And so you need to do things like saving 50%, like investing 50% of your income, increasing your income. Don't take any of this as financial advice. I have just learned it on YouTube from other people. The money that you'll make will be like that. Yep, you'll be ultra rich if you follow this framework. Not financial advice. I just followed this guy. What's his name? Yeah. Profit Plug. Learn everything from him. Profit Plug. Angelo Castello. If you really want to get rich slowly, you'll get rich slowly, but you'll get extremely rich after 50 years, 40 years. That is something I really want for myself. It's for my money to work for me when I sleep. That's annuities future value. Annuities present value is also another concept that I use. So I currently have, so it works in dividend ETFs. I currently have, several, like I have hundreds of dollars invested into a stock called TCSH. So I invested a large amount of money, like all my savings, into this ETF. And so to prevent my hundreds of dollars basically lose value due to inflation. So $100 this year will be worth $98 next year because of the 2% inflation Canada faces. So to prevent my money from losing value, I invested into this TD cash management account, and it gives me about, I think, like some 5% return, or 5% dividend, I think per month or per quarter or something, per year. So I'm just keeping my money safe from inflation. Instead of money lying in my bank account, I invest it here, and it's also very stable. The stock barely like moves, so I barely make a profit or loss. I barely make a loss, but it's very safe, and I can pull it out whenever I want. Unlike stocks that go up really high, woohoo! I made $100 of profit, but currently it's down at like $20. Getting rich slowly requires lots of patience, and you need to not sell your stock if you're investing for your future. That's annuities present value. You invest a bunch of money, and then you earn a smaller amount of money on regular intervals. I have no idea what compound interest present value is. Isn't interest present value meaning? So just, I guess, how much my money is worth in the future. Okay, all right. Logarithms are super important. This is something I didn't learn in grade 11, so I had to force myself in grade 12. I lost. I remember losing marks in my final advanced function exam because I didn't remember this. It's to find C, like this crazy decimal exponent. It's basically this. I didn't know how to do it because I didn't know this. I know logarithms, but it's like I know logarithms, its rules, and how to find the exponent, but I just didn't know this specific trick or this way of doing it, so I lost mark. It was something I'll remember. And yeah, that is an hour of 20 minutes of my grade 9, 10, 11 math knowledge. I'll make another video for grade 12 advanced functions, but it's really fun, honestly. It's not really fun, it's a lot of work, but it's really fun when you can apply all of these when you build projects. So using your knowledge to build projects is what I enjoy. So using spaced repetition, I will prevent my knowledge from forgetting. I will prevent forgetting my knowledge. Ta-cha. Ta-cha. By constantly reviewing radical laws and exponent laws. Okay, that's my plan for the future. Thank you for watching. I benefited from recording this video. I hope you benefited too. See ya.